Application of logarithmic functions. The population of a colony of bacteria can double in 20 minutes. In how many hours will this population cross a million, starting from 100 bacteria in the colony? So the idea here is to take very simple examples but understand major concepts. So here again we have taken the same example, that is population of a colony of bacteria doubling in 20 minutes. Now the question is, in how many hours will this population cross a million starting from 100 bacteria in the colony? So let's get back to a formula. So population at any instance is equals to initial population times 2 over t over doubling time, right? So we can write initial population is 100 for us, 2, and doubling time is 20 minutes. So we'll write it in minutes, which is t over 20. So we get our population at any instance of time where time is in minutes. Question is, in how many hours will this population cross a million starting from 100, right? So we took starting from 100. Now we want million here. So our output should be 1 million. So that means 1,000, right? 10 to the power of 6 equals to 100, 2, and we have t to the power of 20. Now how should we get t? That is a big question. Now we really don't have any way of getting it except for logarithms. The other is estimate. So you can estimate different values of t. For example, you can put t as 10 and then see how close you are to 1 million, and then increase and decrease and get the answer. That's one way of doing it. Now in this video I'm going to teach you the logarithmic way of solving this question. So first step is, let's divide million by 100. So if you divide 1,000, which is 10 to the power of 6, by 10 to the power of 2, you know what you should get, right? You get 2 to the power of t over 20. So that is the first step. So in this, 4 zeros get cancelled off, right? 2 on the top and 2 on the denominator. We are left with 10,000, right? 10 to the power of 4. Let me write 10,000 for the time being. Equals to 2 to the power of t over 20. Now for an exponential function, logarithm is the inverse, right? So since we are working with numbers which are 10, we'll take log to the base 10. Well, we have two options. Since the calculator has log to the base 10 or log to the base e, we can take either one of them. Now we'll prefer to take log to the base 10. So if we take log on both the sides, what do we get? So we write log, and to the base 10 we don't really write the base. This is 10 to the power of 4, right? Equals to log 2 and to the power of t over 20. Now the properties of log is, when the base is same, then it is just the number 4. So we get 4 here, equals to, here we have log of 2, and the exponent t over 20 comes on this side, t over 20, and we get log of 2. From here we can calculate t. Log of 2 is a constant, right? So let's cross multiply and get the value of t. So t is equals to 4 times 20, right? So 4 times 20 divided by log of 2. We can use a calculator and find the answer. So it is 4 times 20 is 80 divided by log of 2. And we get 265.754. So t is 265.75. This t is in hours. This t is in minutes. So we can convert this into hours, right? We can divide it by 60. And we get 4.429. So this is in minutes, correct? So let's write down our answer here, which is t equals to 265.75 over 60 to get it in hours, and we get our answer as 4.29, or we can say 4.429 or 4.43 hours, right? So that is how we can get the answer. Well, basically, when you are working with logarithms in such cases, what we really get here is, let us assume this was, I actually found the value, it was easy to work out, but basically it is the log of this number divided by log of 2, right? So if you get an equation which is of the form of, let us say in general, we have p equals to p0, 2 to the power of, let us say t. In that case, what t is? T will be equal to log of p divided by p0, right, divided by log of 2. So that in general is a formula which you can always apply and get the value of t using logarithms, right? So the time t, when you take log on both sides, you can first divide by p0. So you'll get p over p0. So log of the ratio of these two divided by log of the base. So that is the general formula which can be applied to find the exponent. So that is how we apply logarithmic formula. So we'll have one more example, rather a couple of them, to understand this concept. I hope the point is clear. Thank you and all the best.